Welcome to Knowledge Base. We have a question here that says, find the magnitude and direction of the resultant of the system of forces shown below. So we have four forces acting in the north, east, west, and south direction as shown. The aim of this question is for us to find the resultant of these forces and also the direction of the resultant. It is very simple. Watch how I'm going to do this. The first thing is that we want to assign direction or signs to these forces. So we're going to say the force to the left is negative, the force to the right is positive because they are opposite. The force towards the south direction, negative, and the force to the north, positive. If we agree on these signs, then we can say that the sum of the horizontal forces, which is the sum of the forces from east to west, which we'll call Fx is equals to 4 positive minus 5 negative. So the horizontal force sums up to be minus 1 Newton. Remember, force cannot be negative. The negative sign is only showing direction. It is not as if the force is a negative force. Force is a value that is positive, and so when we're talking about force, we always refer to its absolute value. The negative and the positive are only a show of direction. So when we say negative 1 Newton, it doesn't mean that the force is a negative force. It only means the force is acting to the left, which is what we have ascribed as negative. Similarly, the sum of the vertical force, Fy, is going to be 10 minus 6, and that gives us 4 Newton. Positive 4 because the resultant force is to the north, so that we can draw the effects of the forces as this. You can see that we've drawn the 4 Newton force to the north, because to the north we said positive. Since the horizontal force is negative, we are going to draw 1 Newton to the left. Now you can see that there is no longer negative in front of the 1, because we have represented the negative as a direction to the left. So in the real sense, the force is not a negative force. It is just telling us that the direction of the 1 Newton force is to the left, since we have assumed that to the left the sign is negative. We have to find the resultant R, and if you look at this, you can close up one side of this image to form a triangle. You could close this side to form a triangle, and it becomes a right angle triangle, which means R is the hypotenuse of the right angle triangle. So you can use Pythagoras theorem to obtain R, and from Pythagoras theorem, R is equals to the square root of the sum of 1 squared plus 4 squared, because those are the two forces. This is Pythagoras theorem. 1 square is 1, 4 square is 16. 16 plus 1 gives us 17. So R is equals to the square root of 17 Newton. This is a surd. We can express this in decimal fraction, but we cannot simplify more than this. So the resultant is root 17 Newton. Now back to the direction. We have taken the direction to be alpha, which is the angle the resultant makes with the horizontal. Remember, this 4 Newton force can also be said to be here because they are parallel and equal. If it is here, then it is opposite to this angle, and this is the adjacent. So if we say opposite over adjacent, that is tan. So we can say tan alpha is equals to opposite, which is 4, because this 4 can be said to be here, all over adjacent, which is 1. So that if we obtain alpha, alpha will become the tan inverse of 4, or you can call it arctan 4. And that will give us the value of 76 degrees in the calculator. Tan inverse of 4 is 76 degrees. It means the angle the resultant makes with the horizontal alpha, as noted on this image or diagram, is 76 degrees. So the resultant is 17 Newton at an angle of 76 degrees to the horizontal. It is very simple. Try this simple one. What is the horizontal component of a force of 40 Newton that makes an angle of 30 degrees to the vertical? Please put your answer in the comment section. I hope you enjoyed this video. Like, share, and follow our page if you have not done so. Thank you for watching and see you in our next video.